number 1, sub question number 4. The question says, so the heading is find the union of each of the following pairs of the sets. Alright. The fourth sub question under that is A is equal to X such that X is a natural number and X is greater than 1 but lesser than or equal to 6. Alright. So we have to write this set. We will write it in the form of intervals and also in the form of a roster form. Alright. B also is written X such that X is a natural number where X is greater than 6 but lesser than 10. Alright. So now how do we write this? In terms of intervals, how to write, students? So is 1 included? 1 is not included because X is greater than 1. So we will write A equals curved bracket which means open interval 1 comma. Is 6 included? 6 is included because there is an equal symbol here. So write 6 with the square bracket. Alright. So we will write the tabular form or the roster form of A again. We will also write B in the terms of intervals. So B will be equal to, it is not equal to here, there is no equal to here also. So we will write curved bracket 6 comma 10. Alright. So now what is the roster form? So A can be written as what? A will be equal to, 1 is not included. So 2, 3, 4, 5, 6. 6 and 10 are not included because both are curved brackets here. So B will be again equal to, so numbers between 6 and 10, 7, 8, 9, that's it. Understood? So just read the statement and see the tabular form or the roster form. X such that X is a natural number and X is greater than 1, so starting from 2 but lesser than or equal to 6. So equal to 6 and lesser than 6. So B, X is such that X is a natural number where X is greater than 6 but lesser than 10. So greater than 6, 7, 8, 9, lesser than 10. So this is also right. Okay. So now what we have to find out here? Find the union of the sets. So we have to find out the union. So what will be the union, students? So A union B can be written as 2, 3, 4, 5, 6 union 7, 8, 9. So again A union B can be written as 2, 3, 4, 5, 6, 7, 8, 9. So this will be your right answer. So what did we do here, students? The question was given in the set builder form. We first converted into the terms of intervals, in the form of intervals, and from there we converted into the roster form, and from the roster form we found out the union and finally wrote the correct answer here. I hope you understood this. We will move on to the next question, question number 3, exercise 1.4. The question is telling if A and B are two sets such that A is a subset of B, then what is A union B? So what is A, what is B, they have not given us here. So let us consider some elements under A. Okay, in roster form let A is equal to ABC. Now understand, A is the subset of B, means what can we write B as now? So B can be written as A, B, C, D, correct? So A is a subset of B, means all the elements of A are repeating in B as well. So now what will be A union B, students? A union B can be written as ABC union ABCD, which is equal to ABCD. This is nothing but what? What is this? B. Therefore, finally what can we write? Finally we can write A union B will be equal to B if A is the subset of B. So this will be your right answer for question number 3 under exercise 1.4. Moving on to the next question. Exercise 1.4, fourth question. If A is equal to 1, 2, 3, 4, B is equal to 3, 4, 5, 6, C is equal to 5, 6, 7, 8 and D is equal to 7, 8, 9, 10. What should we find out here? The very first question, sub question under fourth one, A union B. So we have A, we have B. Let's write them both. So A will be equal to 1, 2, 3, 4. B will be equal to 3, 4, 5, 6. So A union B can be written as 1, 2, 3, 4, 5 and 6. So what is the meaning of union, students? Means repeating element should be written only once. So that is what we have done here as well, A union B. Here also we have done the same thing. So repeating elements, A, B, C is repeating here also, so write it only once. And what else is repeating in B? D. So write that also here. Same thing here, 3, 4 are repeating, write it only once. 1, 2 from here, 5, 6 from here. So what is this union called as again? This union is also called as OR. Okay, and intersection is called as AND. Okay, so I hope you got this. We'll move on to the next question again. Going on to the next problem, students. So next sub question, fourth main question, second sub question, B union C. So again we have to find out what is the meaning. So we have to find out what is B union C here. What is the meaning of union here? We have to write the repeating elements only once. Alright. So what is B, students? So B will be equal to 3, 4, 5, 6 and C will be equal to 5, 6, 7, 8. So what are the repeating elements in both B and C? So that is 5, 6 and 5, 6. So since it is repeating, we will write it only once. Alright. So then we can write finally B union C will be equal to 3, 4, 5, 6 repeating. So we will write it only once. Why? Because it is union. 7 and 8 as it is. So this will be your right answer. Moving on to the next sub question, A union C. So again we will write what is A here. A will be equal to 1, 2, 3, 4 and C will be equal to 5, 6, 7, 8. So what is A union C? Writing again the repeating elements only once. So what are repeating, students? None of them are repeating, correct? 1, 2, 3, 4, 5, 6, 7, 8. So we will write this as well as this. So that will be the union of A and C. So that is 1, 2, 3, 4, 5, 6, 7 and 8. So this will be your right answer. Moving on to the next question, B union D. So what is B here, students? B can be written as from the question 3, 4, 5, 6 and D can be written as 7, 8, 9, 10. Repeating elements must be written only once. Any elements repeating in B and D, none of the elements are repeating. So B union D can be written as 3, 4, 5, 6, 7, 8, 9 and 10. This will be the right answer for question sub question number 4. Moving on to the next one, next sub question, A union B union C. So 3 sets we have this time. So what is set A, students? So set A is 1, 2, 3, 4. Set B is 3, 4, 5, 6. Set C is 5, 6, 7, 8. So now A union B union C. So before we write this, I'll tell you, whatever elements in A are, if they are repeating in B and C, okay, even if they are repeating, you have to write it only once. So whatever elements are in B, if they are repeating in C, you have to write it only once. Alright. So 3, 4 and 3, 4 repeating, write it only once. 5, 6 and 5, 6 repeating again, we'll write it only once. So finally A union B union C can be written as 1, 2, 3, 4, 5, 6, 7, 8. This will be your right answer for sub question number 5. Moving on to the next one, A union B union D. So what is A again? A can be written as 1, 2, 3, 4. B can be written as 3, 4, 5, 6. And D can be written as 7, 8, 9, 10. Again it is a union, repeating elements must be written only once. So 3, 4 and 3, 4 repeating here. Apart from these both, nothing else is repeating. Correct? So how do we write this now? A union B union D can be written as 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this will be your right answer for sub question number 6. Moving on to the next question. Moving on to the next question, students. Exercise 1.4, question number 5. See, previously we did union, right? Okay, now we are going to start with intersection. So, union means, what did I tell you, students? Repeating elements must be written only once, correct? But in intersection it is something different. So, union is called as OR, intersection is called as AND, A and D, alright. So, find the intersection of each pair of sets. So, we will start with the very first sub question. X is equal to 1, 3, 5 they have given, y is equal to 1, 2, 3 they have given. So, what is common, students? So, union means you are writing the repeating elements only once, right? Now, in intersection you have to write the common elements only, okay. So, other elements you have to just exclude. So, how do we write x intersection y? So, it is written like this, x intersection y. So, what is x intersection y, students? What are the repeating elements? 1 we have here, do we have 1? Yes. 3 do we have? Yes. Do we have 5? No. So, what are the common elements of x and y? 1 and 3. So, we will write only 1, comma 3. So, this will be your right answer. Understood? And the sets here in sub question number 1, in which form are they represented in? They are represented in a roster form. So, the elements are presented like that. Moving on to the next sub question, number 2. A is the set of vowels in English alphabets, A, E, I, O, U, correct? And B is given as A, B, C. So, again we have to find the intersection here. So, we will be writing A intersection B. So, what are the repeating elements or the common elements here? A we have, B, C we do not have here. So, only one element is repeating, which is that A. So, A intersection B can be written as A only, and this answer will be right. Moving on to the sub question number 3. A is equal to x such that x is a natural number and multiple of 3, alright. B is equal to x such that x is a natural number less than 6. So, it was given in roster form, here also it was given in roster form, here it is given in set builder form. So, let us find out what is A first, we will write here only. So, A will be equal to what, students? X is such that x is a natural number and a multiple of 3. It is a natural number starts from 1, goes on until infinity, and it is a multiple of 3. So, A can be written as 3, 6, 9, and it goes on infinitely. So, B, x such that x is a natural number less than 6, natural number starting from 1, but it is lesser than 6. So, B can be written as what? B can be written as 1, 2, 3, 4, 5, that is it. It is less than 6, not equal to. If suppose equal to was given, then we should include 6. Now, here it is only less than 6, so it is only 1, 2, 3, 4, 5. Intersection between them. So, A intersection B, what is common, students? What is common in both of them? I think it is only 3, correct? 4 we do not have, 5 we do not have, these are multiples of 3. So, here A intersection B will be only equal to 3, and this will be the right answer. Alright. Moving on to the next sub question. A is equal to x such that x is a natural number and x is greater than 1 but lesser than or equal to 6. Okay. And B is equal to x such that x is a natural number and x is greater than 6 but lesser than 10. So, what is A, students, here? A will be equal to natural number greater than 1. So, starting from 2, lesser than or equal to 6, 3, 4, 5 and 6. So, B will be equal to what, students? X such that x is a natural number and x is in between means that is greater than 6 and lesser than 10. So, greater than 6 means 7, 8, 9, correct, lesser than 10, and it is not equal to, right, so we are not writing 10 there. So, again what should we find here? A intersection B. So, what is A intersection B, students? What is common in them? 2 we have, no, 3, no, 4, 5 and 6. Nothing is repeating, alright. So, here nothing is common between A and B, or we can also write 5, and this will be the right answer. Moving on to the next question. Moving on to the next question, students. Exercise 1.4, question number 8, sub question number 2. So, we will read the heading there. Which of the following pairs are sets of disjoint? So there is one term here called as disjoint. So what is the meaning of disjoint set, students? So if you take any two sets and you find the intersection between them, and if there are no elements, means no intersection, means no common elements in both the sets, means that will be equal to what? That will be equal to null. Means there is no common elements between these both sets. So if the condition A intersection B is equal to 5, means there are no common elements between A and B sets, and that is why it is equal to 5. This condition is called as disjoint set. Okay, if any two sets satisfy this condition, then set A and set B are called as disjoint sets. Alright, now the question here is, which of the following pairs are disjoint sets? So let us consider this as A, let us consider this as B. Alright, so let us write A equal to and B equal to. So what is A intersection B here now, students? A intersection B, are there any common elements between them? Do we have A? No. Do we have E? Yes, we have E, so write E. I we don't have, O we don't have, U also we do not have. So A intersection B is equal to E, so which is not equal to 5. Understood? If it is equal to 5, means if there are no common elements between A and B, then A and B are called as disjoint sets. But now here we have the common element E, right? So now A and B are not called as disjoint sets. So this is not a disjoint set. So that is their final answer. Why? Because E is the common element between the set A and set B. Alright. Moving on to question number 9. So question number 9 is set A is given, set B is given, set C is given, and set D is given. So what is set A, students? Multiples of 3. Set B is multiples of 4, set C is multiple of 2, and set D is multiples of 5. And we should find what? The very first one is A minus B. So students, A minus B you can find out in this way, correct? A minus A intersection B. What is A intersection B, students? So from this, multiples of 3 and multiples of 4. What is common here? So common here is, I think it's 12, nothing else is common, correct? So 12 is the common, so A intersection B will be equal to 12. So A minus 12. So remove 12 from A, whatever is remaining, that will be A minus B. Alright. So instead of that, so you can do this, okay, this will be correct. Or instead of doing this, okay, you can directly take set A. What is set A, students? 3, 6, 9, 12, 15, 18, 21. So let's just write that. So that is 3, 6, 9, 12, 15, 18, 21. Minus, we'll write it as it is. Alright. And set B is what, students? 4, 8, 12, 16, 20. 4, 8, 12, 16, 20. So this is set B. So whatever elements are in B, so understand what is this? A minus B. From A, subtract B. What elements are there in B, students? 12 is there in B, right? So 12 is here also. Any other elements repeating here? No. So just remove 12 here. Here also you remove 12. So means from A you removed B. Okay, now what is remaining? So you can finally write A minus B will be equal to 3, 6, 9, 15, 18, 21. This will be your right answer. So you can also do it in this way, which is correct. Or from set A, remove all the B elements. So understand what is written here. From A, remove B. So remove B elements from A, whatever is remaining, that is nothing but A minus B. You can also do it like this. Both are correct. Okay, you can follow any one of them. Anyways, both will be giving you the right answers. Understood. Next, same thing. From the set A, remove all the elements of set C. What is set A, students? Multiples of 3 again. So that is nothing but 3, 6, 9, 12, 15, 18, 21. So from this set, remove all the elements of C. What is C, students? 2, 4, 6, 8, 10, 12, 16. Okay, so that is 2, 4, 6, 8, 10, 12, 14 and 16. What are the common elements? I think we can see 12, correct? 12 is there, 6 is there. What else is common? 2 is not there, 4 is not there, 8 is not there, 14 is not there, 16 is not there. Just remove them. Why are we removing them? Because they are belonging to C. So from A, remove all the C elements. So if these both are gone, what is remaining, students? A minus C can be written as 3, 9, 15, 18 and 21. This will be your right answer. You can also do it in another way. I'll just change the color here. So this can also be written like, this can be written like A minus A intersection C. So this is also correct, students, and this is also right. Any one you can follow. So I think you should follow this, whatever I am doing on the board. Okay, it's pretty easy. Moving on to the next question, A minus D. So from elements of A, subtract D. So D is having 15, 5, 10, 15 and 20. So remove 15, which is common from A and D. So just remove that. Anything else is there, students? Okay, no, nothing else. So A minus D can be written as what now? A minus D can be written as 3, 6, 9, 12, 15 is gone because that is belonging to D. So remaining is 18 and 21. This will be your right answer. Very easy, right? We have two more problems. B minus A. So from B, remove all the elements which are in A. So what is B, students? 4, 8, 12, 16, 20. So from this, remove all the elements which are belonging to A. So 12 is belonging, correct? Apart from that, nothing else. So what is B minus A? B minus A can be written as 4, 8, 12 is gone because we are subtracting A from B, correct? So then we have 16 and 20. This will be your right answer. Very easy, right? So from A, you have to subtract all the elements of, from B, you have to subtract all the elements of A. So that is nothing but 12 we subtracted just now. And we wrote whatever is remaining in B, so that is nothing but B minus A. Moving on to the next question, C minus A. So from C, 2, 4, 6, 8, 10, 12, 14, 16. Subtract A. So 6 is gone, correct? 12 is gone, that's it. 6 and 12, anything else is gone? Nothing else. So what can we write? So 2 is as it is, 4 is as it is, 6 is gone, students. So 8 as it is, 10 as it is, 12 is also gone. So then it is 14 and 16. This will be your right answer. I hope you understood. Any doubts you can comment in the comment section. Okay, I'll be clearing it again. We'll go on to the next question. Okay, students, moving on to the next question. So this is the last question of exercise 1.4. So as soon as we finish this, we'll be starting with exercise 1.5. All right. So the 12th question of exercise 1.4. State whether each of the following statement is true or false. So you have to just tell it whether it is true or false. And also you have to justify your answer. Okay, the very first question, sub question, 2, 3, 4, 5 and 3, 6. Two sets are given. Okay, now just let us consider this as set A and let us consider this as set B. Alright, set A and set B are disjoint sets, they are telling. So what is the meaning of disjoint sets? So I'll write here. What is the meaning of disjoint set, students? So you can call two sets as a disjoint set if and only if those two sets are satisfying this condition, A intersection B is equal to 5. Okay, means there is nothing common between these both sets. Then we can write A intersection B is equal to 5. If this condition is satisfied by any two sets, let us call A and B, then these both sets are called as disjoint sets. Understood? Then these both sets are called as disjoint sets. So let's just see if there is anything common between set A and set B. So can you see anything in common, students? Yes. So we can see 3 and 3 common. So they are telling A and B are disjoint sets, whether it's true or false. So this is false because there is something in common between A and B. If there is nothing in common, then they are called as disjoint sets. Alright. Sub question number 2, A, E, I, O, U representing vowels, let us call it as X. Okay. And A, B, C, D, let us call it as Y. Are disjoint sets, they are telling again. Anything common between X and Y? There is a common element called as A. Apart from that, anything else? Nothing. So there is something common between X and Y, right? So now X and Y are not called as disjoint sets. So this is also false. They are not disjoint sets. Okay. Going on to the next one. Let us call it as set P and let us call it as set Q. Alright. So P is having 4 elements, 2, 6, 10, 14, all are even, and Q is having 4 elements, 3, 7, 11, 15, all are odd. Is there anything common between P and Q? There is nothing common between P and Q because this is even and this is odd. So what can we write here? We can write P intersection Q is equal to 5. Therefore, this is true. That is, this P set and Q set are disjoint sets. Why? Because there is nothing common. That is why we have written 5 here. So what can we write here, students, then? A intersection B here, what is common here? A intersection B here we can write 3, which is not equal to 5. That is why it is false, because it is not equal to 5. Here also, X intersection Y is equal to A and which is not equal to 5. That is why it is false. P intersection Q is equal to 5, therefore it is true, which means P and Q are disjoint sets. Understood? Going on to the very last sub question, 2, 6, 10, 3, 7, 11. Even numbers, odd numbers are disjoint sets. So let us take it as C and D. So anything common between C and D? So there is nothing common because these are even numbers and these are odd numbers. So what can we write? There is nothing common, right? So C intersection D is equal to 5. Equal to 5, therefore C and D are called as what? Disjoint sets. This is true. So this is your final answer here. Final answer, final answer, and final answer. Okay, so this is the end of exercise 1.4. Next, let us start with exercise 1.5.